Hi, this is James from Team 2223G, and I'm going to be teaching you how to control your motorized claw so that each arm automatically maintains its equidistant positions. This is going to be done with Robot C, as you can see on the screen, and since claws have become popular for the Vex Starstruck competition, I thought it'd be a good idea for teams that are making a motorized claw with two motors and don't want to mechanically connect each side of the claw to maintain its positions the same. I'd like to point out before we start that a lot of this code is largely inspired by code posted by James Pierman on the Vex forums. Now to start off, you're going to want to go to Robot, Motors and Sensors Setup to set up your motors. And here, in our case, in our robot, we're using two integrated motor encoders on each motor, and they are VEX 393 motors. And our right motor, our right arm is going to be on port 1, and our left arm is going to be on port 10. We have them reversed because to open and close, claws go in opposite directions. And PID control, although we're going to be using a variation of PID loop, these boxes do not need to be checked. So you're going to want to hit apply, then OK, and that should fix up these pragma statements at the top. One thing to note is that this can also be done with potentiometers very easily. And to set up those, you just want to go to analog sensors in the motors and sensors setup, and then hit type and potentiometer. And it's going to be tuned a bit differently, but it'll be essentially the same code. We scroll down here near our user control task, and the first thing that we see is the static float variable, the PID KP. This is the value that we're going to use to tune our program to depending on your robot's needs. And down here we have PID requested value, which is going to be the value of what we call the master sensor or the master motor. Essentially what this is this master sensor is going to be the value that your slave sensor is going to be following. So down here we have an integer PID sensor current value, and that's going to be the value of our slave sensor. Moving on, we have a float, a PID error, and this is going to be the difference between the master and slave sensor values. And then here we have PID drive, which calculates the power that's going to be sent to the motors. Let me explain the types of variables very quick. We have a static float because it's just going to be a static number that you're going to write down. A static float because a float basically allows you to use decimal points in your variable. We have an integer because the sensor values that we're going to be getting from our integrated encoder modules are going to be integers. Same with potentiometers, I believe. And here we have a float, another opportunity to use decimal points for the PID error and the PID drive. So over here, past inside the user control task, well, let me state first that these variables are outside of the user control task because I like to be able to see the variables in real time in the global variables tab once you install the program to your robot and have it connected so you can see and tune in real time. It's pretty great. And so inside the user control task, you're going to have this while loop, which is just a forever loop, so it's going to keep running the program inside. And here we have these if-else statements, which are basically the power we're going to be sending to the master motor So you can control your claw with buttons on the controller. So we have an if statement. If one button is pressed, then it's going to send 127 power, and else if another button is pressed, it's going to be sent negative 127 power. And then we're going to have else, which says if no buttons are pressed, then the power sent to the master motor is going to be 0. Furthermore, we have our P loop, our variation of the PID loop. The P part, which stands for proportional. This is our proportional code, which allows us to move our claw, our master motor our slave motor proportionally to our master motor. So here we have PID requested value, which is the sensor value of the master motor, which is I2C1 in our case. And then we have the PID sensor current value for the sensor value of the slave motor, which in our case is I2C2. Remember that this is our right side and this is our left side. Note that this is inverted because we want the claw to be sent power of the opposite of what the master motor is. We want the slave to be sent the opposite of what the master motor has. Moving on, we have our PID error variable, which we define as the difference between the master motor and the slave motor. So we have the sensor value of the master motor minus the sensor value of the slave motor. And down here we have our PID drive value, which is the value that's going to be sent to the motors, as you can see down here. Here it allows you to use the PID KP value and multiply that by the error value, so you can tune this code to your liking for your robot's specific needs. Okay, here we go. We have our if statements to limit power to the motor to be either equal or under 127 or equal and above negative 127. And here we have the motor being sent the value of PID drive, and it sends a calculated value to the motor. And here we have this weight, which is basically just a cushion for the program. It's recommended so you don't hog your CPU and so you don't cause any problems. Here we close off our loops, and that's about it. Once again, this has been James from Team 2223G. I hope you found this tutorial helpful, and good luck in this VEX season.